The main purpose in being able to solve these equations is actually use it in the real world. You're like, when am I ever going to use this? So we're going to take these equations and we're going to apply them. We're going to look at some of the basic applications of linear equations.
And now Brother Rich is going to take us through the general process of converting a word problem into an equation so we can solve it.
We are about to embark on the hardest of all math problems, word problems. These are nasty. Raise your hand if you like word problems. What, I got one of you? You're crazy? Okay. Most students don't like word problems. They're challenging. And we're going to talk to you today about how we can address word problems in a way that makes them easier and we are more accomplished in solving them. So first thing, I'm going to be you. You are doing your homework and you read this problem. So pretend that I'm a student. I read this. Brother Baird exercises regularly at the local gym. Recently, they offered a body fat percentage test to its members. Remember now, I'm you. The device used measures the passage of a very low voltage of electricity through the body. Brother Baird's body fat percentage was found to be 16.5%, and he weighs 191 pounds. What part in pounds of his body weight is fat? Okay, so if I'm you, I read that, I think, and then I read it again. Brother Baird exercised regularly at the local gym. Recently offered a body fat percentage test to its members. The device used measures the passage of a very low voltage of electricity through the body. Brother Baird's body fat percentage was found to be 16.5%, and he weighs 191 pounds. What part in pounds of his body weight is fat? Brother Baird exercises regularly at the local gym. Okay, so you relate to this. You read the problem, you read it again, you read it again, and you're still not understanding what you're supposed to do. So let's talk about why do we do this? First of all, we are taught from the earliest stages of our education to read for comprehension. Read to understand. But math is different. I'm not so concerned if you understand this story. This story really isn't going to make any difference in your ability to do the math or not do the math. If you don't understand the local gym, if you don't understand the process of low voltage electricity being run through the body, it doesn't matter. It's not going to make any difference whether you can do this problem or not. So understanding this problem is not what we're trying to do. The first thing we do when we read a word problem is we're going to talk about a process here called DVPE. D stands for data, okay? And we want to read the problem one line at a time. But rather than reading the problem one line at a time to understand the story, we're reading the problem one line at a time because we want to extract, which means to pull out all the numerical data. And when you do this, I want you to label your numbers. All right? So let's read this problem again, and let's write D right here. Okay? So let's read this problem again, and we're going to read it one line at a time. Brother Baird exercises regularly at. Okay? Any numerical data in there? None. That's just garbage. We don't even need that. Move on to the next line. The local gym. Recently, they offered a body fat. Any numerical data in there? None. Again, just junk. Moving on. Percentage test to its members. The device used. No numerical data there either. We can discard that material. Measures the passage of a very low voltage of, again, no numbers. Electricity through the body. Brother Baird's body fat. Again, garbage. We don't need to understand any of this. Percentage was found to be 16.5%, and beautiful. We have numbers. This is what we're looking for. 16.5. And we label this. It's a percent. Okay? And he weighs, next slide, 191 pounds. Again, we have numbers. Now, for those of you who don't use pounds in your local region, this is approximately 87 kilograms, but that doesn't matter. We don't need to convert this. Conversion is not part of this problem. But just for your local understanding, somebody who weighs 191 pounds weighs approximately 87 kilograms. Okay. And we read on. What part in pounds of his body weight is fat? Do I have any other numbers? I have none. So right now, my purpose, not to understand, but to extract the numbers and label them. So I've labeled this percent, I've labeled this pounds. Okay, let's come back over here. What does V stand for? V stands for variable. All right? This part of the problem is the unknown. This is the part we don't understand. We don't have the answer for this yet. And it is often, does often mean always? Nope, it doesn't. But it is often found in the last sentence of the problem, and it's posed as a question. Okay? So let's come back to this problem here. Okay? And let's look at the last sentence. It says, what part in pounds of Brother Baird's body weight, or of his body weight, is fat? Okay? So this is what we don't know. How many pounds of all of his body weight is fat? So we come back here, right here. Let's do this over here. V is our variable, and we're going to, we can pick any letter we want. We can pick X, that's often the most common picked variable, or we could pick, P for pounds, or whatever we want. We're going to do X. X equals pounds of fat. Okay? It's kind of a funny problem, isn't it? All right. So let's talk about this for just a minute. Does the human body, is it all fat? Of course not. Absolutely not. We're composed of bones, and we're composed of skin, and fat, and muscle, and water, all kinds of things, okay? So part of his body weight is pounds of fat. Now, what does P stand for? P stands for plan, okay? And whenever we solve a problem, we need a plan. I like to state straight up, this is the hard part of this problem. This is the part that requires us to think. This is the part that requires us to think. Now, your instructors for these word problems are going to teach you different plans, different ways to think about these word problems that help you. And I'm going to help you with this one problem today and give you this plan. But the plan is where we have to think. Sometimes these are formulas that we have been given previously that we have to memorize. But in all, this is the part where we tackle the problem and think clearly about it. So let's go over here. Our plan. In a percentage problem like this, we have some total number being multiplied times a percent, okay? And that's going to equal a part of that total number, okay? So this is a portion of the total number. This is a plan to attack percent word problems. What is our total number in this problem? Again, this goes back to, is Brother Baird, is his whole body fat? I hope not. He probably wouldn't exist, right? So his total number up here, we think about this, we have 3 items up here. So let's come back over here. E. E stands for equation. We've been learning how to solve equations. And we need to create an equation. So the equation is where we take our data and we plug it into the plan. This will provide us an equation that we now can solve using our three-step process to solving. So, E, our equation. What is our total number of these three entities? Is pounds of fat, X, the total number? Is 191 pounds the total number? Or is 16.5% the total number? Okay, it makes sense. Exactly, 191 pounds. And we don't need the label now because we're just doing the math. We just need the numbers. 191 pounds represents the total body weight times percent. That one makes sense. This one's labeled 16.5%. But we must remember, when we're doing a percent word problem, we always convert percent to a decimal. So this equals 0.165. If you remember, we moved this two places and get rid of the percent sign. So this is going to be 0.165. And what's our part number? Again, only a portion of our body weight is fat, and so X is our part number. This problem works out pretty simple. We don't have fractions or parentheses or even like terms. In fact, all we need to do is multiply these two numbers to have our variable. We're ready to go here. So on a calculator, we multiply 191 times 0.165. What do you guys get? 31.5. Okay, now we need to label this. Pounds equals X. So in all of Brother Baird's body weight, 31.5 pounds of his body is fat. You better keep working out.
And now we'll go through each of the individual kinds of plans that will be valuable for you on the homework.
The first of this application you're going to do is just to translate numbers. Math is actually a new language, and you're going to have to translate from English into math to make it work. So, translate. Twice a number plus 8 equals 26. What is the number? And in this case, twice a number. That means 2 times the number. So, one of the first things you're going to have to do, pick a variable. Usually it's what you don't know. You don't know what that number is, so pick a number. If you're named Rick, pick an R. Pick a Q, L, M, whatever you want. Pick a letter. Because you've got to put a letter in here to represent that number. So a very common one is X. We could use N for number, so we take N. We say twice a number plus 8 equals 26. Now you've just translated from English into math. The reason math was invented is because these things are harder to figure out in English than they are in math. So this is how we're going to do it. So once we get into an equation, we can use our normal way of solving it. Subtract 8, get 2n equals 18. And how do we get rid of that 2? Divide. That number was 9. So that's how translation works. You just kind of read it, and it works that way. There's one very similar to that, but something you have to kind of worry about. And that is 7 less than 3 times a number is 17. What is the number? The reason is less than, you think that, well, obviously that's subtraction. So many people will write 7 less than 3 times a number. We're going to pick P because that's, I don't know, pick a variable, P equals 17. We have to talk a little bit about this. If you consider your age, are you 20, 30, 17, I don't know, and you say, okay, 7 less than that. Note that you don't take 7 minus 18. You took 18 minus 7. When you're doing less than, you have to start with whatever you're going less than. So 3 times the number. Where did I get the P? I don't know. I picked a number. And that's all you got to do. Pick a number for the variable. So 3 times that, and then 7 less than that means we now subtract 7 from that. And that's the one thing that usually causes people a little bit of trouble. So 3p minus 7 equals 17. Now we have it in the equation form. Aha! Now we're back to the math. That's where the world gets easier. Because now we can just add 7 to both sides. We say 3p equals 24. And how do we get rid of that? Divide by 3, divide by 3, p equals 8. So the number must be 8. 7 less than 3 times 8 will be 17. Very similar to this one, this translation of just, okay, that's what they're saying, is we're going to do substitution. Now before we do that, we need to get a few vocabulary words that translate very kind of straight across. And here they are. Equals in math could be the word is, could be the word was, are, have been, equal to, stuff like that. That's is. Plus, this goes plus, add, in addition to, increased by, taxes. Taxes will add on, definitely. Markup, interest, and this is the key word here. The official mathematical word is a sum. When you sum something up, you add them up. And this is what you'll be using in Excel a great deal as a formula to add things up. So that's sum. These have a very similar thing, so that's a minus. Subtract, taken away from. Oops. Taken away from. Decreased by. Instead of a tax, you could have a discount, or a sale, or a markdown. The official math word is difference. For example, the difference between 8 and 5. You think, well, okay, that's 3. Well, how did you get that? 8 minus 5 is 3. So, the next one, multiplication. Have a dot now. So, times, multiply, twice as big, that means 2 times. Thrice as big, nobody uses that very much anymore, but would be 3 times as big. Here's a key, of. The word of. If you have baskets that have 5 apples, and you take 7 of those baskets, the total number of apples would be 35. You've multiplied them. Same thing when we did percentages. If you take 25% of some number, you're going to take 0.25 times that number. Of is a key one there. And the official math word is product. The product of 6 and 7 is 42. And finally, divide. So you divided by, not a lot of other ways they say it. They do say, some people say through or in parts or in pieces of. Here's a key one that's close to this but not the same. Out of. If you say you got 15 out of 18 on the quiz, then that's 15 divided by 18 will give you your percent. So out of is a divide. And the official one, that's the official word, quotient. So you're able to take all these words and these will translate into math.
To the boards!
Hello and welcome back to the boards. In this section, we're going to be working on some translation practice. What we want you to do with these 3 questions is first translate the question from English to Mathanese, and then solve each equation. You can go ahead and pause the video now, and in your video notebook, work on these 3 problems. When you're ready to check your answers, we can go unpause the video and we'll go over them together. Good luck. Okay, here we go. In question number 1, we need to translate the word a number. Okay, that translates to X. Then we have increased by, that translates to plus. We have a 7. The word is translates to an equals, and then we have 10. So that's what this problem translates to. X plus 7 equals 10. We now need to solve it. We're going to solve it by peeling off the plus 7. We got to get X by itself, so we got to peel off plus 7. The opposite of plus 7 is minus 7. So we minus 7 to both sides of the equation, and we'll be left with X equals 3. That's our answer for this first to the boards question. Let's try the next one. 30, okay, is, oh, remember the word is translates to equals. 6 more, oh, that means 6 plus 2 times a number. Remember, more than means plus, and 2 times a number would mean 2x. So we have 30 equals 6 plus 2x. That's what we need to solve. So the first thing we're going to do is undo the plus 6. We'll minus 6 to both sides of the equation. That gets us 24 equals 2x. I now need to get the times by 2 undone. We'll do that by dividing by 2. And when we do that, we get X equals 12. That's our answer for question number 2. Question number 3 is a little tricky because it uses the word less than. Remember, less than means subtraction, but you have to flip the statement. So we're going to have 10 less than 5 times a number. That means 5 times a number comes first. 5x. Then we apply the less than, minus 10. We then have the word is 25. Remember, anytime you see the word less than means subtraction, and the subtraction has to go second. So that's why this 10 came up second. Excellent. The word is meant equals, and so that's where that came in. We're not going to solve this problem. We need to undo the minus 10. To do that, we're going to plus 10 to both sides. Remember, whatever we do to one side, we do to the other to keep a balance. Now we need to get X by itself, so we're going to undo the times by 5. To undo times by 5, we divide by 5, and our final answer is 7. Thanks for watching, and coming to the boards. Keep working hard.
For the second application, we are going to do substitution. And this is very valuable if you are trying to find 2 separate numbers. So let's write this up here. Now we did a substitution thing where you took a variable, like when we had just the expression 3f plus p. We said, what if f is 7 and p is 2? What does this equal? And we substituted and we said, okay, that was 3 times 7 plus 2. Oh, that was easy. This 7 just went in right there, and the 2 went in right there. 3f, which was 7, plus p, which was 2. And we substituted in, and we got 21 plus 2 is 23. Now we have problems where it's going to be very handy to do this sort of thing with variables. For example, 2 numbers add to 93, period. The first is 7 more than the second. What are the 2 numbers? Now if you start thinking, oh, you just look at it and you just look at the numbers like 7. Oh, 86, must be 86 and 7. That doesn't quite fit. It says the first number is 7 more than the second. So they're not separated by a long distance. They're just 7 apart, but they add up to 93. Well, this is where we kind of get to use this substitution. We have 2 numbers. Better put an S on that. 2 numbers add to 93. Well, we need a variable. Let's write that up one more time. Pick a variable. Pick a variable. So we have 2 numbers. We got to pick two of them. How about F for first, S for second? Two numbers add to 93. Now I should note, when you get to these problems, it'd be best to read it first, the whole problem. Two numbers add to 93. The first is 7 more than the second. Then, once you've read it, you should read it again. Two numbers add to 93. The first is 7 more than the second. You should read it a third time. With every single application word problem that you get, you should read it at least 3 times. If you don't get it yet, read it again. Right up until you say, okay, I get the problem. Well, you should realize, once you get to that stage, you're almost done with it. Here, you pick the variable, and it says two numbers add to 93. So the first plus the second has to equal a 93. This would be very difficult to solve this guy. We can't, we've got an F and an S. But notice, here's the second clue. The first is 7 more than, so we can do a 7 plus, a plus 7, more than what? The second one. Now here's where this substitution it just opens this up. You have F, okay? F is this thing. And you can stick it right there, just like we did before. It's not necessarily a number that we're sticking in, but we're substituting right in there. And now I rewrite this equation right here. So now rewrite it. Where's F? Okay, that's my F, plus S. Now we have an equation that we can deal with. We can solve it. Now it's into the math equation. We know S plus S, just on this side of the equation, that's a 2S right there. So 2S plus 7 equals 93. Subtract the 7, should write that down, equals 86. And 2S equals 86, so divide by 2. S equals 43. That tells us that the second number is 43. We've got to find two numbers. So if the second number is 43, this guy's 43 right here, putting that guy right back up in here, then the first number must equal 43 plus 7. Gives you 50. So the two numbers are 50 and 43. And you look at that, two numbers add to 93. They do indeed add to 93. And the first one, 7 more than the second one. And you're able to unravel those type of riddles with math. And that's kind of what the value of math was when it started.
It's time to get back to the boards working on some of these substitution problems. What we'd like you to do is pick a variable for each of the numbers, translate both sentences from English to math, and then substitute one of the equation into the other and solve. Go ahead and pause the video now, give these two questions a try, and when you're ready to check your answers, unpause it, and we'll see how you did. Okay, welcome back. Here we have two numbers that add up to 50. I'm going to go ahead and pick the two letters X and Y, and I know that these two numbers add up to 50. I'm going to call my first number the X and my second number the Y. They then tell me the second number, that's Y, and they use the word is. Remember, the word is means equals. And they tell me 30 more than the first, so that would be X plus 30, because the second number is 30 more than X. Excellent. So I picked my variables X and Y. I translated both the equations. And now I'm going to go ahead and substitute this second equation into the first. Because I know that Y is X plus 30, I'm going to go ahead and take that X plus 30 and plug it into the Y of the first equation. Now when I do that, I'm going to get X plus this X plus 30, and that equals 50. Again, I'm plugging the X plus 30 in for the Y, and I wrote that here like that. Excellent. Now we can go ahead and solve. I'm going to go ahead and let's combine our like terms. X plus X is 2X. And then I got to get X by itself. So I'm going to go ahead and peel everything off so the X gets by itself. The opposite of plus 30 is going to be minus 30. We'll do that to both sides. So we get 2x equals 20. And then we'll need to undo the times by 2 by dividing by 2. We'll get x equals 10. So I know that x is my first number, and that's 10. And so if I come back and now plug it into what I circled here, if I plug 10 back in, I'll know that y is 40. So my two numbers are 10 and 40. You do need to make sure to plug it back in to find that second number. Okay, excellent. Let's see how you did on number 2. Two numbers add up to 118. I'm going to go ahead and use A and B to represent my two numbers. My first number will be A. My second number will be B. You might have picked something else. That's fine. I know that A and B add up to 118. I then know that the first number, that's A, is, remember that's an equal sign, 64 more than the second. 64 more than the second. Okay, good. So I went ahead and picked my A and B. I translated both equations. I'm now going to substitute this A value. I know that A is B plus 64, so I'm going to plug that in for the A, because I know that A equals B plus 64. When I do that, I get B plus 64 plus the B equals 118. Again, I'm just rewriting this first equation, but instead of writing A, I wrote B plus 64. Now we can solve. Add my B's together, I get 2B plus 64 equals 118. We need to undo the plus 64, so we minus 64 to both sides. When we do that, 118 minus 64 comes out to be 54. I've got 2B equals 54. We'll divide by 2 to get B by itself, and I find out that B is 27. Now I need to go back and find what my first number is. To do that, I'm going to plug it back in to where I circled here. If B was 27, I know that it was 64 more, and so I get A is 91. So my numbers are 91 and 27. Great work at the boards. Keep working hard in this section.
And the final application that we're going to do right now is shapes. We kind of already did one of these, but we'll do another one. You have a whole bunch of formulas for a whole bunch of shapes. So we're going to pick one. This is a sphere, and it has the following formulas: that the surface area on this sphere is 4 times pi times the radius squared. Now we should stop a minute and make sure you understand what that is. The area, so all these little, if you had little patches right here representing the area, you have a radius in here. If you took this radius of like 5 inches and you squared it, and then you were able to times it by 4 and times it by pi, then you'd be able to get the entire surface area, all these little patches. That's one of them that we could use. You also have this formula: volume equals 4/3 pi r cubed. And you remember that these tell you the dimension of what's going on here. Now, on these type of problems, we would give you a radius. Say the radius is 7 inches. And you'd stick it in here and you'd use the formula to get these. Now we're going to make sure you can go backwards all the time. Let's do one where you have a circle, just a circle, and the circumference is 2 pi r. If I, instead of giving you r, give you c, so I say, oh, circumference is about 50 inches, and I want you to find the radius, then we're going to use our ability to solve equations to do that. You stick 50 inches in right where the c is, 50 inches. 2 times pi times the radius. Well, if I want to get radius by itself, we're going to divide, because it's timesing here, get rid of it, divide by the 2 pi. So the radius is going to be, 50 divided by 6 point something. It's going to be 7 point something. I'll let you punch that in on your calculators to get it. But you're able to take these, stick them into the places they are, and then go ahead and solve it. Just remember that pi is just a number. It's not a letter, it's not a variable, it's just a number that can be divided off. And that's the first section of applications.
Welcome back to the boards. We've been discussing shapes, and it's time for you to practice some shape problems at the board. When you do these problems, make sure to follow the following 3 procedures. First of all, identify the formula you need. Most of those formulas you're going to find in section 2.2 of your textbook, so you might want to have that page handy. Then, once you have the formula written out, you're going to plug in the given values. Lastly, solve for the unknown value that they want you to find. So we have 3 questions here for you to try. Go ahead and pause the video now, and when you're ready to check your answers, unpause it and we'll work on it together. Good luck! Okay, here we go. We've got a triangle that has an area. Oh my goodness. Area of a triangle. Now you might not have that memorized, and so you might have to go to section 2.2 and find it. Once you find that, you're going to find out that the area of a triangle is 1/2 times the base times the height. So that's the first thing you got to do. Identify the formula. Okay, now we need to plug in the given values. They tell me that the area is 100. Okay, and that the base is 20. So I've got 1/2 times 20 times h. Okay, our goal is to find the height. This is what we need to find right there, that h. So let's go ahead and combine like terms. I'm going to do 1/2 times 20. That gets me 100 equals 1/2 times 20 is 10h. I need to get h by itself, so I'm going to go ahead and undo the times by 10. To peel off a times by 10, we divide by 10. And 100 divided by 10 is just 10. So that means my height is 10 meters. And that would be my final answer for number 1. Number 2 is a little tricky. They give us the actual shapes and the measurements, and we need to find the area of the shaded region. To do this, notice that the area that's shaded is only the rectangle minus the circle. So we're going to have to do a rectangle area minus a circle area. So the area of a rectangle is length times width, and the area of the circle, again, this would be something you want to grab from section 2.2, is pi times r squared. So this is the formula. We needed to do the rectangle minus the circle. The area for the rectangle is length times width, and the area for the circle is pi r squared. So let's plug in the length. The length of the rectangle is 10, and the width is 6. So we have 10 times 6 minus pi times r squared. Now r is the radius of the circle. So the radius starts here and goes to the very top. So it would be half of the total height. The total height is 6. The radius would be 3 inches. So it's going to be 3 that I plug in. Okay, 10 times 6 is 60, minus 3 squared is 9, and if I did 9 times pi, I'll use 3.14. We get 28.26. So we need to do 60 minus 28.26 to find the area, and we get 31.74. Because this is the area, my answer will be in inches squared, or square inches. Okay, that was an interesting problem. Cool, we found the area. Okay, let's keep going here. We now need to find the length of a rectangle, which is 5 centimeters more than its width. I feel like I almost want to draw this one out. You could if you wanted to. It says that the length is 5 more than the width. So if I called the width x, that would mean that the length is x plus 5, because it's 5 more than the width. Okay, and then they start talking about the perimeter. They say find the length and the width if the perimeter is 45. Well, we're going to need the perimeter formula. Perimeter formula of a rectangle is P equals 2 L plus 2W. Now we're going to plug in our known values. They told me the perimeter is 45, and they told me that the length is x plus 5. So I'm going to put that in for the length plus 2 times the width, which is just x. We have parentheses in this problem, so we're going to need to distribute into the parentheses. So I'm going to take the 2 inside and multiply it to each of these. That gets me 2x plus 10. And here the 2x, well, then we just get 2x equals 45. I do have a bunch of x's, so I'm going to go ahead and combine them. 2x plus 2x, that's 4x plus 10 equals 45. We're going to go ahead and minus the 45 over. I get 35 equals 4x. And then we need to divide by 4. So x equals, let's see, 35 divided by 4 comes out to be 8.75. Now they asked me to find the length and the width. So 8.75 is what x is. So that would mean that's the width. So 8.75 centimeters is the width from here to here. To find the length is x plus 5. So we're actually going to have to take this 8.75 and add 5 to it. When I do that, I get 13.75 centimeters for the length. And so that's my final answer. We'd say that the width is 8.75 centimeters and that the length is 13.75 centimeters. And that is our answer for number 3. Thanks for reviewing shapes with me. Good luck on the rest of your assignment. Keep working hard.
Lastly, we'll show you how to work with variables on both sides of the equals sign.
Okay, you've now finished something that goes about like this. 22x plus 8 equals 15. You're like, we can solve that. That's not a big problem. You're going to peel off just like an artichoke. Get the x by itself by first getting rid of the positive 8. You do that, well, subtract 8 on both sides. 2x equals 7. So now I have 2 times what equals 7? I don't know. How do we get rid of that 2? Well, it's attached with a multiplication, so we get rid of it with divide. So we have x equals 7 divided by 2. You can leave it as 7 halves or as 3.5, either way. This next section that we're going to talk about is just a little bit different. You have something like this. 2x plus 8 equals, 3x minus 7. Now, we run into a problem here. The major principles that we've been talking about to begin with are that you have the x and you get this x, it's in the center of all these numbers that are piled around it, and you've got to unpeel things. Well, here the x's are in 2 separate places. They're not even together. This is where that power of balancing comes in. You remember this balance thing that we did. Here you have your equation with the equal sign right here in the middle, and it's almost like that's the hinge. And whatever's on this side, you can add, subtract, multiply, or divide anything, so you get the exact same thing on both sides. Well, here, the problem is that, well, we've got a 2x on one side and a 3x on the other, and we want to get rid of one. That's really the biggest question. How do you get rid of one of them? Well, you are all powerful. You can say, I don't like the 2x, so you get rid of it. As long as you do it to the other side, you're safe. So you have a 2 minus the 2x here, minus the 2x on the other side. This is now gone. 3x minus 2x, that's x minus 7. Now the x's are together. They're on one place. They're combined. So you can take this. Okay, now let's peel off what we've got. We've got a minus 7 right here, so let's get rid of the minus 7. Opposite of minus, plus. We have x equals 15. 3x plus 5, in parentheses, minus 2 equals a 7x plus 3. Oh boy, we got to get rid of those parentheses. I don't like them. That's a distributive property. Take and jump this 3 in here. We have 3x plus 15 minus 2 equals a 7x plus a 3. Combine what we can combine. We have a 3x, what is that? 15 minus 2 is a plus 13. equals 7x plus 3. Now again, the two x's you'll see right here, just like we had up in the other problem, are in two separate places. And you can't just combine them and make them 10x. They're not together. So we have the 3x here, the 7x there. We've got to get rid of one of them. We don't like them. We've got to put them in the same place. So you can pick. In this case, I don't like that one. So let's get rid of him. And you just subtract 7x. It's like having that balance and just saying, you know what, here we're kind of balanced. Let's take that much off of that side of the balance. Subtract 7x here, and we now have negative 4x plus 13 equals 3. Now that the x is together, we can peel off just like we normally did. Subtract 13 for both sides. And then we divide by a negative 4. We have x equals, two negatives cancel, give you 10/4, which reduces to 5/2. Or if you punch that in your calculator, 2.5. There are a couple of concerns that may arise with this. You can certainly use this anytime you need to move the x's from one side of the equation to the other. But the problem that comes up, I'll show you in this next one. Let's do something like 2x minus 5 plus 3x equals 5x minus 7. Do it the exact same way we've been doing it. Get rid of those parentheses. We have 2x minus 10 plus 3x equals 5x minus 7. We have a 2x and a 3x on this side. We can just put them together. They're 5x. They're both together. 2x and 3x is 5x. Now we see that these x's are in two different places. Let's get rid of one of them. Subtract the 5x. Subtract the 5x. We're left with negative 10 equals a negative 7. At this point, the student should pause and reflect. Ponder a little bit on what he has just created. When we're going down here, we have an x that we're dealing with, all the way down till we say, oh, x is this number. Here we have just eliminated every single x in the entire problem. It should give you some worry, in fact. We created a statement that says negative 10 equals negative 7. If you use a number line or just do a little bit of counting, you will realize that that is a not true statement. Absolutely false. No matter what x is up here, this is a false statement. It could never be true. In that case, where this one says this thing's going to be true if x equals 2.5, this over here will never be true, no matter what x is. And so it gives rise to the possibility that you might have no solution. There is no number out there that will ever make negative 10 equal negative 7. Right here, there's one number that will work here, and that's 2.5. That's why it's a solution. However, over here, no number will ever work, so we get no solution. By a minor adjustment, a very similar thing will happen with a completely opposite result. So if we did something like 3 with these x minus 5 plus 4x equals 7x, something like that. We're going to do the same thing we did before, jump the 3 in. Now over here we have a 3x, we have a 4x. They can combine. You have a 7x minus a 15, 7x minus 15. And here we have, you should see, something funny's going on. That's exactly what's happening. Something funny is going on. They're the same thing. Continue. In case you didn't see it, go ahead and go down one more step and you subtract the 7x. And they're gone. Gone. You get this statement is always true, no matter what x is up here. Whereas here, when the x's went away, we ended up with a statement that was false. Didn't depend on x, it was just a false statement. This one is true, no matter what x is, and so that means we could stick anything in the world for x. So we can write it like this. X is a very special R, meaning real numbers. They just put 2 lines on it. So when x goes away, if you end up with a false statement, x can't ever work. And if you end up with a true statement, you get x as all real numbers. That's the kind of problem when you have x's on both sides of the equation.
Hello and welcome back to the boards. We've been looking at problems that have lots of variables. Variables on the left, variables on the right. It's time for you to practice 4 of these types of problems. When you do these, here's a couple hints or procedures you should follow. First, if you have parentheses, you should distribute into the parentheses. Second, combine your like terms and then get all the variables on the same side. Third, you're going to solve the problem. And fourth, if this does happen sometimes, if your variables cancel out, then you'll have to decide if your answer is no solution or all real numbers. Go ahead and pause the video now and practice these 4 problems in your video notebook. When you're ready to check your answers, unpause the video and we'll work on them together. Good luck. Okay, here we go. Question number 1, we've got 7x plus 10 equals 2x minus 40. First thing I need to do is distribute parentheses. We don't have any parentheses, so we don't have to worry about that. Step 2, combine like terms. Let's see, is there anything that can combine? I don't see anything, but we do need to get x's to the same side. So let's go ahead and minus 2x to both sides. That'll make it so that all the x's are on the left side. 7x minus 2x is 5x plus 10 equals negative 40. I now need to work on solving this. I need to get x by itself, so I'm going to undo the plus 10. We're going to minus 10 to both sides. When I do that, I get 5x equals negative 50. I need to get x by itself, so I'm going to divide by 5, and so I get my answer is x equals negative 10. That's our answer for number 1, using those 4 procedures. Let's take a look at number 2. In number 2, first thing we need to do is distribute parentheses. Yeah, we've got parentheses here, so this negative 2 on the outside is going to need to get distributed into the parentheses. So negative 2 times 3y is negative 6y, and negative 2 times 2 is negative 4, minus 7 equals negative 3y plus 1. So we distribute it into the parentheses. Next, we need to combine our like terms. Oh, we do have a 4 and a 7 that can be combined. Let's do that. Negative 6y. Negative 4 minus 7 is negative 11. We also need to get our y's to the same side. So let's go ahead and plus 3y to both sides. That way they're all on the left side. We could have moved them to the right, but I picked the left. Negative 6y plus 3y is negative 3y minus 11 equals 1. Okay, I'm running out of room here, but I think we'll be all right. I need to get the y by itself, so I'm going to do a plus 11 to both sides. When I do that, I get negative 3y equals 12. And then we'll divide by negative 3 to get our final answer, which is negative 4. Okay, great. So now for number 3. Step 1, distribute parentheses. I'm going to distribute the 2 in. When I do that, I get 2x plus 14 equals x plus 14 plus x. It now says to combine like terms. If I combine my like terms, I've got an x and an x over here. I would get 2x plus 14 equals 2x plus 14. I need to get those x's to the same side. So minus 2x over. When I minus 2x over to both sides, oh, something weird happens. The x's cancel over here and here. And I'm left with 14 equals 14. Notice that the 2x minus 2x, those x's just disappear. If that happens, that's where we got to apply step number 4. If the variables cancel, we have to decide if it's no solution or all real numbers. Because this is a true statement, it's all real numbers. And you can write out all real numbers or use an R. That works out too. So when it's true, you use all real numbers. That's what you say your answer is. Number 4. Step 1, we're going to have to distribute into the parentheses. I can do that. We're going to take this negative 3 into the parentheses. So I get m. And when I take that in, I get minus 6 plus 3m equals 4m minus 8. Let's go ahead and combine our like terms. M plus 3m, that's 4m minus 6 equals 4m minus 8. We now need to get them to the same side. So minus 4m over, oh, the same thing's going to happen. The 4m's cancel out. I'm left with negative 6 equals negative 8. Now that is a false statement. So we solved it. The x's canceled, and because it's a false statement, we say that our answer is no solution. This problem has no soul. Excellent. Well, great. We solved 4 equations with lots of variables. Great work at the boards. Keep working hard.